Assalamualaikum and a good day to Sir Nurulhalim Bin Hassim. We are from Group 7. The group members is Jansen, Luqman, Kelvin, Jonathan and myself, Norasida. We will present our assignment entitled Design a Link Budget Calculator using Matlab GUI. So next. Okay, the content consists of objectives, introduction, safety and legal issues, simulation data and results, discussion and conclusion. For the next slide. Okay, here is the objective of this assignment. Firstly is to write a Matlab GUI program for link budget calculator. Secondly is to be able to compare the theoretical value and simulation parameter values with high accuracy. Thirdly is to be able to calculate the link budget of the system. And lastly, to be able to understand the theory of link budget. So I'll pass to Jansen for the next slide.
Okay, first of all, so why do we need link budget? The definition of a link budget is the calculation of different factors that is used to estimate the power transmitted from the Earth station to satellite and vice versa, where satellite to Earth station. And this is helped to have a reasonable amount of reception power at the ends. And link power budget is used to be for the calculation to help design a proper link. And there are two quantities that is used as the association of the calculation of the power budget of the satellite link. These quantities are the transmit power and also the receive power. Link budget calculation is defined as the determination of power relative to transmission and reception, and the equivalent isotropic radiated power, or EIRP, is the key parameter of a link design calculation. So next. So what is the need of a link budget? Well, first of all, there are various losses and gains that occur during the communication of satellite system. These losses and gains are produced due to which there are factors that affect the performance of satellite system. And the combination of study on the losses and gains is very important to get the idea of the actual performance of the whole satellite system. And also to regulate the performance of the system in adverse conditions, the study on the losses and gains is needed to be applied. And lastly, the calculation of the link budget is a crucial aspect that is related to satellite communication. The link budget calculation will optimize the various losses and gains in the system. For example, for the uplink, there are losses specific to uplink, such as the atmospheric losses, and from both uplink and downlink deal with losses related to temperature. So the unit of the link budget calculation is usually done in decibel and decilog quantities. Next. So this is the link budget equation, which can be formed after looking at all the possible factors where possible gains or losses can occur between the transmitter and the receiver. We have the received power, transmitted output power, and the transmitter antenna gain, the receiver antenna gain, and the transmitter feeder and connector losses, and also the free space or path loss, and also the many-sided signal propagation losses, and also the receiver feeder connector losses. Next. So moving on to the safety and legal issues. So for the safety issues, ever since the launch of the first satellite, which is the Sputnik 1 in 1961 by the Soviet, which marked the start of the space age. So satellites have then been a cornerstone that led to the high-paced development of communication-based technology, and now a pivotal part of the technology infrastructure of our society. So it stands to reason that one of the very basic safety concerns nowadays is simply the disruption of the satellite services, but mainly the communication satellites, because disruption of simply by maybe a 1 hour or can cause huge losses, and also disruption that caused by maybe a potential terrorist group or by natural causes such as colliding with space debris. The disruption can cause potential loss of millions to companies and also affect the ability to share information on contact our loved ones or anyone that we need to contact at the time, and disrupt the convenience to interact with the many devices that rely on our services. Since we live in a society where basically our mobile devices can interact with other devices, such as buying a train ticket, for example. So this can cause potential, and also this can cause potential mass panic out of fear from it being a terrorist attack, and following it will be chaos and disorder. And it will be hard for the government to actually calm down people because the communication services is temporarily down. Moving on to the legal issues. So as the advancement of satellite technology develops, the cost needed to send satellite to space has sharply decreased over the following years and becoming more and more commercial. But the laws and legality surrounding has not caught up yet. The issue of legality is then more focused on the lack thereof and the effort adapted into recent times. So the treaties that were formed back then have not really been included or adapted to include our recent modern landscape. And the treaties generally assume that the state is the primary handler of this kind of technology, but fail to include the recent commercialization of the internet satellite. For example, SpaceX. So the laws surrounding both commercial and state are being handled separately, leading to a very fragmented legal landscape. So one of the more concerning issues then is regarding to the space debris, which is a collection of junk such as bits and pieces of rockets that split off during launch and satellites that are no longer in services, and generally found near low Earth orbit around the 1,000 kilometers and below 2,000 kilometer altitude. So with the commercialization of space, the debris is only increasing, and the rate that it is going, the debris will hinder and ultimately prevent our further travel into space. There are no laws addressing the removal of debris and holding the parties that engage to space. It is principle, which is a huge debt if we were to maintain our access to space in the future. I will pass it then to my next teammate to present.
Okay, for simulation data, as we can see, first we assume the data value, but for each parameters, including frequency, speed of light, antenna diameter, aperture efficiency, satellite distance, system temperature, noise temperature, losses, power transmitter, noise bandwidth, and Boltzmann constant. So we just assume the value by the suitable parameter, which is as the table given. So for the frequency, we use the Q-band model satellite. Then because we use Q-band, because it has frequency range between 11 until 14 gigahertz. For the Q-band, it have 1.2 meter until 1.8 meter. So the aperture efficiency also suitable, which is around 55% until 60%. To make sure the design is reasonable, we choose the 55%. So the satellite distance from Earth also covered not much not much far, which is 40,000 kilometer. So next. Okay, this is the manual calculation that have been calculated. So first we use the wavelength. So as we know, wavelength is speed of light over frequency. Then we get the actual value for the calculation. So the next one is the antenna aperture. So we calculate it, then we get the same too. So the effective aperture. Then we calculate the transmitted gain. So the difference is on the receiver gain, which is around 5 or 5 point something different from from the from the experiment value. So because I think because of the wavelength of the wavelength use, or the the antenna aperture get obtained, so it have a slightly different. So for EIRP is also the same, receive power also the same, power transmitter also the same, and same as to flux density. So next slide. This is for the free space path loss, which is we call it as LP. So we calculate it and then get the at the actual value. The noise power also the same. So MPSD, which is the noise power spectral density, also the same. For carrier to noise, also the same. This is the different, which is the GR value is different. So the figure of merit, we get the slightly different from the actual value. So same as to CNO, also get a different value because of the antenna gain, antenna receive gain. So I give to next candidate for reason.
Okay, here is the demonstration for the calculator that we already that we have designed. So first of all, type guide in the command window, and then I will open the calculator that already have been designed. And this. Okay, the next step is to insert all the assumed data. So this is the first calculation that we built. Copy this and insert into the data section. Then next, the same state. As for the flux density, we cannot calculate this because we still haven't got the value for the PT and GT. So moving on to the next calculation. Same goes with this, since we haven't got the value for the GR. Okay, this can be calculated since we have the EE and lambda. Copy this and input into the GR section. This is also cannot be calculated since we haven't got the value for GT. Complete this. And now we already have the value for GT. We can use this value and compute the value for power receive. So this is power receive. Okay, for this one, we already have all values, so we can compute the data. Okay, now all the calculator is complete. So the function is if we want to change from the unit test or from something to dB, we can use this converter. So we change it to convert to dB. So that's all for demonstration. Thank you. Okay, so as for the simulation results, so this is the output from the design that we have done in Matlab GUI. As we can see, at the enter data here, we input the data that we already assumed and discussed before. And then below here is the where the calculation will be done. So as we have the value of frequency and the assumed value, we can compute each of the value and calculate until we get the results. For the next slide. Okay, so this is the comparison table of theoretical and simulation value. As we can see, the value for both of theoretical and simulation value are really close to each other. This is because the formula used inside the coding is correct. That's why we got a really close value towards compared to the theoretical value. So moving on to the discussion, I will pass to Jonathan.
So next I will discuss about the discussion. First of all, we set all the needed parameter. Then we calculate the wavelength by using C over F, and the frequency is 11 GHz. C is the speed of the light. Then we get the result is 0.02727 meter. Then next is the effective aperture. We use the aperture efficiency, and we get the antenna and the antenna aperture, and we calculate it. Then we get the effective aperture is 1.3996 meter squared. So next is the antenna aperture. We use the antenna diameter is 1.8 meter, and the theoretical and simulated result are same, which is 2.5447 meter squared. For the transmitter gain, the parameter used is the efficiency, diameter, and the wavelength, and the result get is 2.805095 dB. Then next is the receiver gain parameter used is the effective aperture, wavelength. Then we calculate and get the result is 43.7377 dB. So next is the effective isotropic radiated power, ERIP. We use the transmitted power, and we calculate the result is same as the calculation theoretical and simulation, which is the 31.1052 dB watt. So next, so for the received power, the parameter used is the power gain, the transmitter gain, transmitter power, and aperture. And the satellite distance is 40,000 kilometer, and the result is 1.6324 times power of negative 13 watt. Then the transmitter power, we calculate 2 watt, same as the simulation. For the flux density, the result is 6.4149 times 10 power of negative 14 watt per meter square. So next is the free space path loss. Then we get is the 205.311 dB. Then next is the carrier noise to noise ratio. Then the result we get is 230.8088 dB. Then last is the figure of merit. Then we calculate the result is 22.946 dB. So in conclusion, we are able to write the Matlab GUI program for the link budget calculator. Next is we can compare the theoretical value and simulation parameter value with high accuracy. Besides that, we are also able to calculate the link budget of the system. Lastly, we understand the theory of the link budget more deeply. Like the conclusion we stated it, we are successful to achieve the goals that set up. So that's all of my from our presentation. Thank you.